say it that way. No, we didn't. All right. So we've already talked about area under the curve a little bit, but when we did rerun sums, we focused on when the curve was a positive function. Well, suppose we want to find the area between sine of x and the x-axis from 0 to pi. Look at the picture. Sine is not positive in that entire interval. That's part positive, part negative. To compute the area of the region bounded by the graph of a function and the x-axis, when the function takes on both positive and negative values, we must be careful to break up our interval into subintervals in which the function does not change sign. So, our function, we're looking from 0 to 2 pi. What you have to do is find all of the zeros. So, I actually asked you the question. How do we determine the interval to break the interval into? How do we determine the interval to break the integral into? Find the zeros. So if you look at the picture, sine is 0 here, here, and here. In order for a function to change from positive to negative, it has to cross through a 0. It's continuous. And we're working with continuous functions here. Non-continuous calculus 2. Have fun. Maybe I'll see you there. Once you find the zeros, then you just have to integrate in between them. So we'd integrate from 0 to pi, and then from pi to 2 pi. The answer will actually tell you if you're positive area or negative area. So this guy, if you were to integrate from 0 to pi, your answer would be 2. Down here, if you were to integrate from pi to 2 pi, the answer would be negative 2. Meaning it's a negative area under the x-axis. What you are looking for is the total area. Total area, you take the absolute value of every section and add them all together. So if you want the total area of this picture, it would be 2 plus the 2 minus 2 plus 2, which would be a total area of 4. Right? So let's give this a shot. Actually, no, set this one up, write it out. So the total area equal to, well, we need our limits of integration. So we're over 10, we did not see that picture, so we're going to solve. We need the zeros of our function. Remember, we're only going from 0 to 2 pi, so we only need to solve sine of x equals 0 in that interval. So go around your circle. Sine is 0 when x is 0, when x is pi, and when x is 2 pi. If that's not familiar to you, shoot me an email and I'll find you a YouTube video on zeros of trig functions. This is really great. Use it. You could be asked about sine, cosine. Tangent will be calculus 2. So yeah, sine and cosine are the ones you really need to worry about. Alright, so what we're going to do is we're going to find the total area by integrating, starting at the beginning, 0, to our first 0. We're going to stop at pi. We're going to integrate sine of x, yes. And then we're going to integrate from pi to 2 pi. Sine of x. Notice I did not put a sign in the middle. That is actually a question. What do we put in the middle? Well, you have a couple ways to do this. You can find one integral, find the other integral, find the answer, and make them positive and put them together. Well, the actual notation would look something like so. The absolute value of each one of these, I don't know which one's going to be negative, and you add the two together. So let's work this out. We're going to do the integral from 0 to pi. Sine of x dx. Move that down so I can come back and fill in my answer later. What is the antiderivative of sine? Careful. Twice about that. Negative cosine of x. Bracket from 0 to pi. This is a case where I'm not going to put a bracket in the front to show the other way of writing this. You don't have to put a bracket in front, especially if you only have one term. So we evaluate the top first. So plug in pi, so negative cosine of pi, minus, minus is in the formula for the fundamental theorem of calculus, and then we have a minus cosine at 0. Make sure you understand what that would be, minus f of x. Let's cosine at pi. Negative 1, you have a negative, so it's a positive 1. Minus cosine at 0. 1. We have a negative. If it's negative 1, we have another negative. 1 wanted, we could make this easier on ourselves and make both of these positive or plus. All right, what's cosine of 0 and 1? There we go. So we get 2. And that's what the picture showed as well. So we got it right. This is the first part. So not the answer. This is just the first area. So we go back to our total area. It's equal to 2 plus, we got to find the other one. So let's integrate now from pi to 2pi. Same function, sine of x dx. The nice part is, you've already done an antiderivative. So you did it right. Always check the work. Negative cosine of x is the antiderivative. But now we're evaluating from pi to 2pi. So we plug in 2pi first. So negative cosine of 2pi minus a negative cosine of pi. If you want to plug in 2pi, find cosine of 2pi, and then write that there, that's fine. You can skip a couple steps. You don't have to write this part out if you just want to go to the next one. So negative cosine of 2pi is 1. I'm going to get rid of some of these things here. But plus cosine of pi, oh wait, that's negative 1. Negative 1 makes negative 2. So that is the area under the curve. The total area is the positive version of each of these added together. So 2 plus 2 equals 4 as our total area. Total area. One more. Alright, if you want to pause and try something wrong, you're more than welcome. Yes, Chick-fil-A. Not my parents. I don't think. Alright, find the total area between the graph of this curve and the x-axis over the interval from -3 to 2. Well, we probably need to make sure that this function is positive everywhere. So let's look and see if there are any zeros in this interval. If there's a 0 in this interval, we're going to integrate in between the endpoints and the 0. Alright, so let's look for zeros. Negative x squared minus 2x, we're going to set that equal to 0 and factor. So they both have a negative and they both have an x. We pull that out, what's left? X plus 2. So the zeros are at x equals 0 and x plus 2 equals 0 or x equals 3 to 2. Well, we're integrating from -3 to +2. Both of these values are in the interval we're integrating over. Let's try number 1. Here's -3, here's +2. Our 0, so the first one will be -2, the next one will be 0. We have to separate these out. We're going to integrate from -3 to -2, then from -2 to 0, and from 0 to 2. If you want to check the sign of your function in between, that's fine, you can do that. I'm just making it a little bit less algebra work and just integrating all of them separately. It works as well. Alright, so we are integrating. Actually, let me write out the full thing first. So the total area that we're looking for is going to be the integral from -3 to -2 plus the integral from -2 to 0 plus the integral from 0 to 2. Our function negative x squared plus 2x dx, negative x squared plus 2x dx, negative x squared plus 2x. All three of these are the same function. So if we find the antiderivative once, we're good. Let's actually just do it right here. That'll be less right. So the antiderivative, that would be power rule. So add 1 to the power, divide by the new power, plus add 1 to the power, and divide by the new power, the 2's cancel. This is from -3 to -2. And then they're all the same inside. So write your antiderivative, or check your work, go for it. The limits of integration for the second one were from -2 to 0. Now I'm going to use my fancy computer to realize I need more room, shift it over. Plus the antiderivative, same thing again. This time we're evaluating from 0 to 2. Alright, let's evaluate. I'm going to work out a little bit as we go so I don't have too much writing. Let's do colors. That way you can see where everything comes from. First color. I'm going to go with this one, whatever. Oh, purple. Okay. So if we plug in -2. -2 to the third power is -8. -8 and -1/3 make +8/3. Negative 2 squared would be plus 4. Minus. So plug in the negative 3. Plug in the top limit, and plug in the bottom limit. Negative 3 plugged in. Negative 3 cubed would be negative 27 divided by negative 3 would be a positive 9. Negative 3 squared would be a positive. Alright, so that is the first integral area. Next one. So plus. We plug in 0. What happens if we plug in 0 here? All 0. That's it. Minus, if we plug in the negative 2, well, we already did that one earlier, but I want to make sure I got it right. So negative 2 cubed means negative 8. Negative 8 and negative 1/3 make 8 over 3. Plus, negative 2 squared would be 4. Where's my blue? Ah, there. Alright, last one. So plus, we plug in 2. 2 cubed is 8. We're coming on a negative, so it's going to be negative 8 over 3. Plus 2 squared is 4. We plug in 0, we get 0. Alright, work it out. I'm not going to get common denominator, I'm just going to clean it up, and hopefully some of the fractions will cancel out, or add together or something. So we have 8 over 3, plus 4. 9 plus 9 is 18, so it's negative 18. What? Nope. 0, then we have negative 8 over 3. Minus the 4, because we have to distribute this negative if I'm not going to combine those numbers together. Minus another 8 over 3 plus the 4. Alright, let's cancel stuff out before we try and get common denominator. So a positive 8 over 3 and a negative 8 over 3. Positive 4 and a negative 4. So negative 18 minus 8 over 3 plus 4. Oh wait, let's put that 4 and that 18 together. So the negative 18 and the positive 4 make negative 14. Alright, we gotta put these together. So 4 is over 1. Common denominator will be 3. So multiply by 3 to top and bottom. It'll be negative 42 over 3 minus 8 over 3, negative 50 over 3. Wait, I did it. I really did it, didn't I? I did. Shoot. Okay. I forgot to make them positive. So remember, when you do this total area, you have to put the absolute value on each integral because you got to make them positive. Okay, go back and fix that because I was being confused. You get carried away with the integral. I forgot my notation. So that means we have to make sure each of these individually is positive. So I cannot cancel all of this stuff out. I'm sorry. For that last row, that was wrong. Luckily, I got a negative, otherwise, I totally would have forgotten. Careful. Alright, so 8 over 2, where is that section? Alright, so the purple part is this section here, so that's going to be positive. The green part is this section here, which has to be positive, plus in the middle. And the blue part is this section here, don't forget plus in the middle. Alright, so now we got to work it out. So we have 8 over 3 minus 14. All that has to be positive. Plus, right, we get a common denominator here. So that would be negative 8 over 3 minus 12 over 3. So get your absolute value. Plus, that's a common denominator here. Negative 8 over 3 plus 12 over 3. This guy's going to get a common denominator. He's just going to be 42 over 3. I'm just going to fix him right here. These two make negative 14, which becomes negative 42 over 3. Alright, work it out. So, 8 minus 42 would be negative 36 over 3. So get your absolute value. Plus, negative 20 over 3, absolute value. Plus, 4 over 3. It's already positive, so I don't need an absolute value. The absolute value just makes everything positive. So we have, well, 36 divided by 3 would be 12. Positive because of the absolute value. Plus, 20 over 3, positive, plus the 4 over 3. Alright, combined, so 12 plus 20 and 4 are both over 3, so 24 over 3, plus 12 plus 24 divided by 3 is 8, and your total area is 20. So this is saying that if part of your curve is above, and part of your curve is below, and then another part maybe is below, I don't know. You actually had 2 negatives. I'll do it later. You take all of these sections together, I don't know. Take all of these areas individually, make them positive, add them together, you get 20. If you do the correct thing. Alright, that is this section, the total area. Make sure you know if your function is positive, then just integrate across the entire interval. If it has some zeros, it's probably in some negative sections. If you integrate the whole thing and you get a negative, maybe the whole thing was negative. The area is always going to be positive. Have fun with your homework, email me with questions, let me know what I can help you with, and study hard.